Hi guys, today we'll discuss this trigonometry and counting problem from Waterloo's Grade 10 Cayley contest. This is question number 23 from year 2017, and I asked that the triangle with side lines 6, 8, and 10 is right angled, while the triangle with side lines 6, 8, and 9 is an acute triangle, and the triangle with side lines 6, 8, and 11 is an obtuse triangle. An obtuse triangle with positive area has side lengths 10, 17, and x. If x is an integer, what is the sum of all possible values of x? Well, my first reaction to this question is that, okay, this requires some patience. But before we approach this question, we really need a solid understanding of trigonometry as well as a concept called triangular inequalities. Triangular inequality says that the third side of any triangle must be less than the sum of the other two sides. Well, why is that? Suppose let's take any arbitrary triangle, right? Doesn't have to be right angled. Let's call this A, B, and C, right? Three side lengths. Let A side be 3, B side be 4, right? Fix these two side lengths and let the angle between A and B be called theta, right? So we ask the question, what is the upper bound of C, the third side, right? And we know that if you fix A and B side length, right, C will grow if the angle between A and B, or theta, grows bigger. And we know that theta can at most be 180 degrees because the sum of all interior angles of a triangle is 180 degrees, right? So at the extreme case, theta is 180 degrees, which means that A and B, these two sides form a straight line, flat, right? And the straight line's length is going to be 3 plus 4, which is 7. And if C were to close off, right, this shape, then C must take on the length of 7. The problem is this flat line doesn't have any area, right? It's just a line. So in order for this thing to have a positive area, C must have a length of less than the sum of A plus B, right? So that means C must be less than 7. So this is the intuitive understanding why the third length of any triangle must be less than the sum of the other two sides. Okay, a related question is there a lower bound for C, right? So let's take the other extreme case of theta, right? The angle between A and B. Suppose theta is at the smallest possible value. Let's say theta is 0. That means A and B are going to overlap, right? Side by side, and the gap between the other end is going to be 1 because that's the difference between 3 and 4. So if C were to close off this shape, C has to fill in this gap, take on a length of 1. And of course, the problem with this shape is that it is a flat line and doesn't have any positive area. So in order for this shape to take on a positive area, C must be slightly bigger than 1. So therefore, C must be greater than the difference between A and B, so the other two sides, right? So take the longer of the other two, subtract the shorter of the other two. So 3 minus 4 or 4 minus 3, you get that C must be at least a little bit bigger than 1. Now let's get back to this problem. The question asks, okay, you have an obtuse triangle with 3 sides. One of them is 10, right? And the other is let's call it 17. And the unknown side is called x, right? It doesn't have to look exactly like this because we don't know which one of the 3 angles is obtuse. And actually, because of that fact, we should break down this problem into 3 cases. The first case is that the obtuse angle is formed by the 10 side and the 17 side. And the second case, the obtuse angle is formed between the 10 side and the x side, which is this angle. Or in the third case, the obtuse angle is formed between the x side and the 17 side, or this angle right here. Right. So let us start with case 1. Right. What if the obtuse angle is formed between the 10 side and the 17 side? Right. Let's call this theta. So we know that an obtuse angle is something that is greater than 90 degrees, and also, but of course, has to be less than 180 degrees, right? So based on the triangular inequality, we know that there's an upper bound for x, right? So x will have to be less than the sum of the other two sides, which is 10 plus 17. This is the triangular inequality we just saw. So x should be less than 27, strictly, right? And because x can only take on integer values, right, we have the upper bound for x to be 26, less than or equal to 26, right? This is the upper bound of x. Okay, so this is when theta is really big, right? So what about as theta shrinks, right? How small can x can x be, right? So the limiting case happens, right, or the boundary case happens when the angle between the 10 side and the 17 side is exactly 90 degrees, right? Because as soon as it hits 90 degrees, this ceases to become an obtuse triangle. So let's say, right, at 90 degrees, the Pythagorean theorem would hold true, right? So that means x must equal to the square root of 10 square plus 17 square, right? And this value is approximately 19.7. Right? So we know that as soon x, right, x starts at 26, keeps going down 25, 24, 23. As soon as it hits 19.7, this ceases to become an obtuse triangle. Therefore, x must be greater than 19.7. And if x were to only take on integer values, x can only be greater than or equal to 20. That's your lower bound of x, right? So therefore, x can be 26, 25, 24, all the way down till 20, right? In total, there are 7 values of x. Now let's consider the second case when the obtuse angle is formed by the x side and the 10 side, right? So imagine a triangle that looks something like this, right? As remember that theta, right? This angle can at most be 180 and should be greater than 90, right? So as a theta gets really big, right? This thing becomes flatter and flatter, right? So like this angle gets closer and closer to the 17 side, right? And which means x actually will get very small, right? And we know that x has a lower bound, right? It keeps getting smaller until a point, right? Until the fact that use the triangular inequality, we know that 17 should be strictly less than x plus 10, right? Triangular inequality, right? So we know that if you move 10 to the other side, you have x is greater than 7, right? And of course, since x can only take on integer values, x should be greater than equal to 8, right? This is what happens as theta gets really big, which means x will be super short, right? But we know that x should be at least 8 due to the triangular inequality. Okay, what if theta gets smaller? So that means this point will keep getting further and further away from the 17 side. So that means this this triangle will keep getting fatter and fatter, for the lack of better words, right? And when does it stop? Well, the boundary case happens when this angle is exactly 90 degrees, right? Because at that point, this ceases to become an obtuse triangle. According to the Pythagorean theorem, if this were to be a right angle triangle, we know that x is equal to the square root of 17 square, the longest side, hypotenuse, minus all the shorter sides, which is 10 square, right? 17 square minus 10 square, and this value is approximately 13.7, right? So we have an upper bound for x. X should be less than 13.7, right? X keeps growing. It should stop as soon as it hits 13.7. And since x can only take on integer values, x must be less than or equal to 13, right? So therefore, x can be 8, 9, 10, all the way until 13, right? In total, there are 6 values for x. Now, onto the third case. It's actually the most interesting case because it is impossible, right? You're asking the x side and the 17 side to form an obtuse angle, which means like this third side must be the longest side. But according to the question, the third side must be 10, which is shorter than one of the sides, which is 17. So therefore, in this case, it is impossible for the x side and the 17 side to form an obtuse angle. Actually, even a right angle is impossible. So therefore, in total, you have 3 cases, right? The first case, x can be 20 to 26. In the second case, x can be 8 to 13. And if you sum them up, it should give you the answer of 224.